Hello everyone, welcome to Tourism Mhlongo's Mathematics and Physical Science YouTube channel. Um, we're back with our preparations for the trial exam for mathematics. Today we're looking at mathematics paper 1 from Mpumalanga, which was done last year. And first question, algebra. And in this question we'll be looking at question 1, which is algebra. And this can be done by learners who are also doing grade 11. So let's get right to it. Right, question 1. Question 1 states 1.1.1. You have to solve for x given a 2 minus x multiplied by an x plus a 3 equals 0. And that's what it's like there. And this is already following the zero law, so we'll just take each bracket and equate it to 0. So this is 2 minus x equals to 0, or x plus 3 equals to 0. And then we can take x to the right hand side or 2 to the right hand side. So either or, this is equals to minus 2, and divide both sides by minus 1, then x is equals to a positive 2, or x is equals to negative 3. That's it. And then 1.1.2, we have a 3x squared minus 4x equals to 5. Then to 3x squared minus 4x equals to a 5. This has to be a quadratic equation, so or in the format of a quadratic equation. So we'll just say 3x squared minus 4x. Take the 5 to the left hand side, becomes minus 5 equals to 0. And to solve or to save things up, the question did not tell us whether, well, normally there's a hint that the answer must be rounded off to two decimal places. But in here, they did not say anything. So we can just simply label our value of A and B, which is minus 4, and C, which is a minus 5. Then we use the quadratic formula, which is x equals to minus B plus or minus all over B squared minus 4AC all over 2A. And let me change color. We substitute. The substitution is the one that gives you marks. Plus or minus square root of, and if you can see, each and every substitution has it has brackets. 4AC, so it's a 3 times negative 5. And stretch out the square root, and then it's all over 2 times a 3. And this becomes a 4 plus or minus. And then normally I'll take the calculator and punch everything that's inside the square root. And in doing that, I got a 76 all over a 6. And that means x is equals to 4 um, plus or minus square root of 6 over uh, square root of 76 all over 6. Then this means x is equals to 4 plus square root of 76 over 6, or x is equals to 4 minus square root of 76 over all over 6. Then we take two decimal places according to the instructions in the second page of the question paper. So this will be 2 comma 1 2, or x is equals to a negative 0.79. Right, let's look at 1.1.3. Says square root of 5 minus x, negative x, or minus an x is equals to 1. Right, 1.1.3 says square root of 5 minus x minus an x is equals to 1. Now, we cannot simplify anything here without removing the square root, but before we can remove the square root, we need to make sure that there is nothing next to it. So we can simply say the square root of 5 minus x. When we isolate it, we remove negative x to put it on the right hand side, becomes 1 plus x. And therefore, we can then now rewrite 5 minus x. Why do I rewrite in this equation? So that I can easily square without losing what I had formed um, at the top. All right, and then when I apply the square root on both sides, I get a 5 minus x is equals to, opening two brackets, 1 plus x, 1 plus x, and this is 5 minus x, which is equals to 1 plus x plus x squared. Okay, this color is not nice. 5 minus x equals to 1 plus 2x plus x squared. Okay, now we can put it into the proper format, whereby we're starting with x squared plus 2x plus x plus 1 minus a 5. And that will then give us 0 is equals to x squared plus 3x minus 4. Then we can simply open two brackets to factorize, put x in x, and then we put 4 and a 1. Then it's a positive 4 and a negative 1. Right, now the last part, x plus a 4 equals to 0, or x minus 1 equals to 0, and x is equals to a 1, or x is equals to a minus 4. The last part, we'll have to test whether these values are true for this first equation that we're given here, which is the root of 5 minus x minus an x. Does it give you equal to a 1? So call it the test. So we just plug in the value here. If you say square root of 5 minus negative 4 minus a negative 4, what do we get? Oh, minus a negative 4. We get a square root of 5 plus, well, square root of 9. 5 plus 4 is 9, plus a 4, which is equals to a 3 plus a 4, which is equals to 7. And that is not true to our right hand side. So it's not equal to our right hand side. Let's test the other one. Square root of a 5 minus 1 minus 1, which gives us a square root of 4 minus 1, which is 2 minus 1 is equals to 1, which is equals to the right hand side. And therefore, that means this value is not true. So either put a cross into this equal sign or say NA. Second last question. Oh, not second last. It's dead last. 1.1.4 x into x minus 5 less than 0. Simplify or solve for x. That's an inequality. Right. We have an x, or at 1.1.4, we have x into x minus 5 less than 0. This has already been factorized, so we can simply go to critical values, or CV. Now x is equals to 0, or x minus 5 equals to 0, then x is equals to positive 5. Now we draw a small graph, then we put our values 0 and 5, and then since it says less than, it's looking for the values that are found below 0. and in between these x values. So this is 0 less than x less than 5. That's why it's 2 marks. Second last question is our simultaneous equation. Solve for x and y simultaneously from minus 2y plus x is equals to a negative 1 all over, well, not all over, and the second equation being x squared minus 7 minus y squared is equals to a negative y. Right. So we'll start off with 1.2 being minus 2y plus x is equals to 1. We label it as equation 1. And then we have an x squared minus 7 minus y squared equals to a negative y, which is our equation 2. Then we have to make a third equation because there's no equation that defines either x or y. So we choose the simplest, which is equation 1. So therefore, x is equals to a 2y plus 1 or 1 plus 2y. It's the same. So that's equation 3. And then we substitute equation 3 in equation 2. That's mostly quadratic. So we first write the equation 2, which is x squared minus 7 minus y squared equals to minus y. So wherever there is x, we substitute for 2y plus 1. So that you can say 2y plus 1 squared minus 7 minus y squared is equals to minus 1. And we can simply expand this. Oh, I made a minor mistake here in copying the question. This is not a plus 1, it's a minus 1. So always double check your question. It's a minus 2y plus x equal to negative 1. So luckily we hadn't done a lot. So we need to put a minus here and also put a minus here. Is our eraser. Minus. And before we can substitute, eraser, it's gonna be 2y minus 1. Then we open the 2 bracket for 2y minus 1, 2y minus 1, minus 7 minus y squared equals to negative y. Then we can simplify that into a 4y squared minus 2y minus 2y plus 1 minus 7 minus y squared plus a y equals to 0. Right, now we can go on with grouping like terms and adding like terms. So 4y squared and another y squared is a negative y squared. This gives us negative 4y. Then there's another y here which is a plus y. And then we have a number here which is a plus 1 and a minus 7 equals to 0. Right, we've grouped them. Then now it gives us a 3, positive 3y squared minus 3y minus 6 equals 0. Then we can divide throughout by a 3. And y squared minus y minus 2 equals to 0. That can simply be factorized by opening 2 brackets. So y, 2, and 1, negative and positive. So y minus 2 is equals to 0, or y plus 1 is equals to 0. And y is equals to a negative 1, y is equals to a 2. Right. When you get to this stage, you can just say when y is equals to 2, what is my value of x? Take it back from equation 3, which is x is equals to 2y minus 1. Then now substitute 2 into 2 minus 1, and that's a 4 minus 1, which gives the value of a 3. And when y is equals to negative 1, x is equals to 2 times negative 1 minus 1, which is negative 2 minus 1, which is negative 3. There you have it. And the last question is prove that the roots of the following equation are non-real for all real values of a and b, where a is not equal to 0 and b is not equal to 0, for the equation that says a squared x squared plus abx plus b squared equals to 0. Alright, we want to prove that something is non-real. First, what do you know about non-real? What do you know about non-real? Now, when you talk of non-real root, you're talking about a discriminant that is less than 0. And our equation here looks far more bit complicated, if I can call it. It's an a squared x squared plus abx plus b squared equals to 0. And we know we can only get the discriminant from a x squared plus b x plus c equals to 0. Now, we need to identify the value of a, the value of b, and the value of c to put into the formula for the discriminant. And in this equation, you can clearly see that a squared is related to this a, and then the ab is related to the b, and then this b squared is related to the c. So this means we can easily label that our value of a on the discriminant is a squared, our value of b is ab, and our value of c is b squared. Then our discriminant is equals to b squared minus 4ac. Then we substitute. When we substitute, get ab squared minus 4 times a squared and b squared. What do we get for this? We get an a squared b squared minus 4 a squared b squared. So if we have an a squared b squared being subtracted by 4 a squared b squared, you're going to get a negative 3a squared b squared. That means the discriminant is a negative value. So which means therefore the discriminant is less than 0. What is the value of the discriminant? It's a negative 3a squared b squared, of which is true that it's less than 0. And therefore you can say that your roots are non-real, provided a is not equal to 0 and b is not equal to 0. Thank you. Please like, share, and subscribe.